In this class, we are going to discuss about resistance, conductance, resistivity, conductivity, molar conductivity, electrolytic conductivity, and factors affecting molar conductivity. These are the very fundamental topics. Most of the discussion is a theoretical discussion today, right? So my suggestion is to take note down all the things. Sir, hello, hello. Ma, is it okay? Ma, can you see the dark screen or the black screen? Can you able to see my writing on the screen? Resistance. Okay. Okay. Note down. Okay, dear students. You might have heard about this word resistance in physics, particularly. In physics, you might have heard about resistance. What is resistance? And we are all familiar with the concept conductance. We know about conductance. Conductance related to conductivity, electrical conductors, electrical insulators, all these things. Then what is resistance? Okay, resistance is an obstruction. Resistance is it has an obstruction to flow. Obstruction to flow. So just to make you the concept easier, I will give you one small example. I'll take two metals. Say for example, magnesium metal and silver metal. And silver is a very good conductor, is a very good conductor, or best conductor we can say. And magnesium also good conductor. But among magnesium and silver, the conductivity of silver is greater than magnesium, or magnesium conductivity of magnesium is less than silver. Silver is a very good conductor. That means the resistance of magnesium is more. Magnesium is having more resistance, so its conductance is less. Whereas silver is very good conductor, I said no. That means it is having very less resistance. That means this conductance and resistance both are inversely proportional to each other. Resistance is inversely proportional to conductance. Here conductance can be represented with the letter C. But in our textbook, in NCERT textbook, conductance is represented with the symbol G, capital G. So we will follow this only. So resistance and this conductance both are inversely proportional. That means here you no need to worry about the definitions and all. Just you see what is the meaning of resistance, what is the meaning of conductance, that's enough. So simply if any material having more conductance, it acts as a good conductor, right? If it is if any material or any metal or non-metal is having less conductance, that means it's having more resistance. If resistance is more, conductance will becomes less. That's all. And now we'll discuss some fundamental concepts about this resistance and conductance. Okay, before going to that, you might have studied about Ohm's law in physics. Ohm's law. What is Ohm's law? Here I'm not going to write the complete definition. If you want, you can write the definition. Just I will pronounce the definition. Ohm's law states that potential V, potential or potential difference V across the conductors is directly proportional to current. Potential difference is directly proportional to current. This is Raoult's law. Sorry, Ohm's law. Potential difference is directly proportional to current. Now here proportionality is there, no? Now we are going to remove that proportionality. V is equal to, in the place of this proportionality, we are using one constant. This constant is taken as R, I. So what is R here? R is called a proportionality constant. It's also called a resistance. Resistance, right? So where we got resistance? We get resistance in Ohm's law, right? Actually, Ohm's law states that potential difference is directly proportional to current. I'm not going to exact definition. It's not necessary. Just you try to get the relation. All of you, my suggestion is to note down. Next, resistance units. What are the units of resistance? You might know. Units of resistance is ohm.
Ohms.
Ohms. Okay. It is represented by this symbol. Ohm. Okay. Next, let's come to conductance. I already told you what is conductance. Simply definition no need. Definition no need. Conductance is represented with the letter G. Conductance is reciprocal to resistance. Conductance is reciprocal, means opposite to resistance. That is G is equal to 1 by R. That's all, very simple. G is equal to 1 by R. And you remember up to this is enough. Now, can you tell me the units of conductance? Units of conductance. Conductance is reciprocal to R, no? That means that is equal to 1 by units for resistance is ohm. Ohm. That is 1 by ohm. 1 by ohm is nothing but ohm inverse. Ohm inverse. This can also be written as, I am writing here, ohm inverse. This can also be written as MHO, mho. Arey, Reha, Ashan? Itla, no? MHO, mho. Right? This is just opposite to this. If you invert these letters, close M, M, H, O, mho. Ohm inverse or mho or Siemens. Siemens. Okay, na? You might know this, and that's all. This is about conductance. Okay, got the point? Now we'll come to resistivity. Resistivity, note down. Resistivity. 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 Resistivity is represented by the letter rho. This is not P. This is pronounced as a rho. Okay. What is resistivity? So before going to know about resistivity, we'll discuss one more small concept. Resistance of a substance. You take any substance. Say for example, if you take magnesium metal, this magnesium metal have certain length of the material. Suppose L is the length of the material. And area of cross section. Area of cross section is A. Capital A or small a. Whatever you want, you can take A. Area of cross section A. This is a magnesium metal. Magnesium is a metallic conductor. The length of the material is L and its area of cross section is A. Now, how this length and the area of cross section related to resistance? So, experimentally it was proved that resistance is directly proportional to length. What does it mean? When the length of the material increases, resistance also increases. When the length increases, resistance also increases. When length decreases, resistance also decreases. And resistance is inversely proportional to area of cross section. Resistance is inversely proportional to area of cross. Means if area of cross section is less, then resistance will be more. Okay, both are inversely proportional. This is the relation between length and area of cross section with resistance. Here also there is a proportionality, no? To remove this proportionality, we use a equal symbol, that is equal to, or is equal to. Here we need to use one constant. That constant is rho. Rho into L by A. That's all. Rho into L by A. Here what is rho? Rho is nothing but proportionality constant. Rho is proportionality constant. Here rho is also called resistivity, specific resistance. Specific resistance. Or it is also called resistivity. Resistivity. So rho is called resistivity or specific resistance. But according to IUPAC, what is IUPAC? International Union of Pure and Applied Chemistry. This is international union. According to this organization, they suggested that to use resistivity instead of specific resistance. So here onwards, we are going to use the term resistivity. Okay, what is resistivity? Resistivity is nothing but rho. Okay, now what I am going to do, I am going to just modify this formula. R is equal to rho into L by A. No? From this formula, what will be the uh, uh, terms? If you write the formula in terms of rho, what will be? Rho is equal to R into, come on, R into, you keep rho here itself, you send this L by A to left side. Then L by A becomes A by L. So this is the formula of resistivity. Note down all these points, note down. This is resistivity. Now, if you want to know the definition of resistivity, what is resistivity? If you want to know its definition, and we'll do one thing. If area of cross section is taken as 1 centimeter square and the length is taken as 1 centimeter, that means area of cross section is 1 unit, length is 1 unit. Then these two becomes 1 and 1, no? If they becomes 1 and 1, then rho is equal to R, no? Rho is equal to R. What is rho? Resistivity. What is R? R is resistance. So how can we define this? Resistivity rho is equal to, see here, resistivity is equal to resistance. Resistivity is equal to resistance for unit area of cross section and unit length. So that's all. This is the definition of resistivity. Resistivity is equal to resistance for unit area of cross section and unit length. What's the formula? Rho is equal to R into A by L. Okay. I hope you have written this. Note down this. Okay. Now, what is the unit? Unit for rho. Unit. So rho is equal to R into L by A. No. What is the unit for resistance? Resistance unit is ohm into length unit. Sorry, it is A by L. A by L. A by L. A by L. A is area, no? Area of cross section. Area means centimeter square. And length unit, centimeter. Centimeter square and centimeter. Square and centimeter get cancelled. And here only centimeter left. So unit of rho is ohm into centimeter. Remember this, unit of resistivity is ohm centimeter. What is the unit for resistance? Resistance unit is ohm. Resistivity unit is ohm centimeter. It is CGS unit. If you want in a SI unit, and it will be in SI unit, it will be Siemens meter. Siemens meter. Siemens, S for Siemens. Sorry. Ohm meter. Okay. Next, you come to specific conductance. What is specific conductance? And in the just a few minutes back, I told you conductance is reciprocal to resistance. Conductance is reciprocal to resistance. Similarly, specific conductance is reciprocal to specific resistance. Specific conductance is reciprocal to specific resistance. Specific conductance, I am going to write here, you also can note down. Specific conductance. Specific conductance is represented by the symbol K. Actually, it's not K, it should be pronounced as kappa. It's a Greek letter, kappa. But usually for our simplicity and to make the concept easy, in most of the case, most of the teachers pronounce it as a letter K. Actually, it's not K, it is kappa. This is the symbol for specific conductance. So, specific conductance is reciprocal to specific resistance. Okay. Dear students, just a few minutes back, I told you rho is called what? Rho is called, okay, just here I have written. Rho is called specific resistance, or it is also called as a resistivity. But according to IUPAC system, we have to pronounce it as resistivity instead of specific resistance. Similarly, conductance, specific conductance can also be pronounced as conductivity. Conductivity. Okay, but according to IUPAC system, we have to pronounce it as, we have to call it as conductivity instead of specific conductance. Okay, very simple, nothing. Till now, what we have discussed? We have discussed resistance, conductance, specific resistivity, and conductivity. These are the four things, right? Here, resistance, G is reciprocal to resistance, and kappa is reciprocal to resistivity. Okay, these are the things you need to know. And now, what is a unit for resistivity? Just we discuss now. Unit for resistivity is ohm centimeter. Ohm centimeter. Can you tell me the unit for conductivity? Unit for conductivity, kappa. Unit for conductivity. It is reciprocal to resistivity, no? Resistivity unit is ohm meter. So, for example, then that becomes equal to this ohm and meter. If you take to numerator, it becomes ohm inverse, meter inverse. So that means the unit for conductivity is ohm inverse, meter inverse. So, okay, these are the few things we need to know basically: resistance, conductance, resistivity, conductivity, and their relations. The most important thing here is units. Units are asking in the competitive exams, but this topic is not important for your board exams, that is CBSE or your intermediate board exams. For that purpose, it's not that much important, but for competitive exams, knowing all these things is necessary. Next one, the most important one, molar conductivity of electrolytic solutions. These are the very important topics that now we are going to discuss. Molar conductivity. Note down. Molar conductivity of electrolytic solutions. Electrolytic solutions. After that, we will discuss equivalent conductivity of electrolytic solutions. First, molar conductivity of electrolytic solutions. Here in this term, molar, the word molar represents mole. I think you know about mole in the previous classes. In the beginning, during fundamental basic classes, I have explained you about mole concept. If you have not attended that class, you can watch the YouTube videos that are already uploaded in my channel. What is mole? Mole is a number actually. Its value is 6.022 into 10 raised to 23. Okay, molar. Okay, what that is the value of mole. Suppose if you take any substance. Now I'm going to take sodium hydroxide for example. Sodium hydroxide. What is the atomic weight of sodium? Atomic weight of sodium 23. Atomic weight of oxygen 16. Atomic weight of hydrogen 1. Total 23 plus 16 plus 1. Total 40. If you take 40 grams of NaOH, that is called 1 mole. 1 mole NaOH means 1 mole sodium hydroxide means that is equal to how many grams? 40 grams. It consists of how many formula units? How many NaOH units? 6.022 into 10 raised to 23. Getting my point? 1 mole means its molecular weight, gram molecular weight. I will take one more example. Hydrochloric acid, HCl. What is the molecular weight of HCl? Hydrogen atomic weight 1, chlorine atomic weight 35.5, total 36.5. Okay, if you don't know about these atomic weights and all, you please watch the previous that basic videos, and after my class I will share that video in our WhatsApp group. You go through that, and it's not a very lengthy class, and just 15 to 20 minutes, that's all, and you will get most fundamental concepts in that class in that video. Now 36.5 grams of HCl means 1 mole. Okay. Now 1 mole of HCl consists of how many HCl molecules? Same. 1 mole means any compound of 1 mole means 6.022 into 10 raised to 23 HCl molecules. Okay. Now molar conductivity. Okay, molar. What is a molar? Molar means mole. And how to know the number of moles? Just by knowing its molecular weight. Likewise, we can take any number of examples. I'll take one more examples, but I will go little fast. H2SO4, sulfuric acid. Hydrogen atomic mass 1. 2 hydrogen atoms are there. 2. Here hydrogen 1, 1. But here only one hydrogen was there. I have taken 1 atomic mass 1. But here 2 hydrogens are there. I have taken 2. Sulfur atomic mass 32 plus oxygen atomic mass. Oxygen already here I have mentioned 16. Oxygen 16. How many oxygens are here? Total 4 oxygens are there. 16 fours are 64. If you add all these things, you get 98. So 98 grams. 98 grams of sodium sulfuric acid means 1 mole. That 1 mole consists of 6.022 into 10 raised to 23. Likewise, you can calculate the number of moles. Now, what is molar conductivity of electrolytic solution? Now, I will tell. Sorry, I have taken one beaker, some water, and some water. Now, into this beaker, I am going to add 1 mole HCl. 1 mole HCl. Here HCl I have added. You know that when HCl is added to water, what happens? It splits into ions, H plus and Cl minus ions. H plus and Cl minus ions. These ions in this solution, they move freely. H plus ions and Cl minus ions, these ions move freely from one place to another place. The movement of these ions causes electrical conductivity. So how electricity will be conducted through any medium? By the movement of electrons or by the movement of charge, by the movement of ions. Okay, understood? When HCl is taken in a water, HCl splits into H plus and Cl minus ions. These ions move through that solution freely. Due to the free motion of these ions, it causes electrical conductance. That is called molar conductance. Why we are using the term molar here? Because we have taken 1 mole of the substance. You can take 1 mole, half mole, 2 moles, 3 moles, whatever the quantity you want, you can take. But if you take particularly 1 mole, it's called molar conductance. Now, shall I tell you the definition of molar conductivity? If you want, you can also note down. Molar conductivity means the conductivity due to due to all the all the particles produced by 1 mole of the substance. 1 mole of the substance. You can take substance or you can write electrolyte. Electrolyte is better. Electrolyte. Do you know what is electrolyte? What is electrolyte? Electrolyte means a substance which undergo dissociation or which allows the current to pass through it in molten state or solution state. I'll give you examples. HCl is an electrolyte because it splits into H plus and Cl minus. Sodium chloride is an electrolyte because it splits into Na plus and Cl minus ion in molten state or solution state. And potassium chloride, K plus Cl minus. Likewise, these are all electrolytes. But if you take sugar, sugar is not electrolyte. Glucose is not electrolyte, C6H12O6. These are not electrolytes because they do not produce any ion. Electrolyte means which produces ions or which able to conduct electricity. Now this is the definition of molar conductance. Conductivity due to, see here, conductivity due to all the particles produced by 1 mole of the substance. Okay, that is molar conductivity. And here I am going to give you one important formula. All of you note down. Molar conductivity, I forget to tell you. Molar conductivity is it can be represented with the symbol lambda m. Molar conductivity is represented by the symbol lambda m. Right. Lambda m is equal to, molar conductivity is equal to K into, it's not K actually, kappa into 1000 by m, capital M. Write down this formula. All of you write down this formula. What is lambda m here? Lambda m is molar conductivity is equal to K is conductivity or specific conductance. Just a few minutes back we discussed. K is conductivity. M is molarity. Molarity means concentration. And if you want its units, you can also write units. Units for K, already you have written per mole. Unit for K, it is opposite to resistivity, no? Right. Okay, at present you write the unit of lambda m. It is equal to ohm inverse, centimeter square, and mole inverse per mole. This is CGS unit. CGS unit. If you want in SI unit, it is Siemens meter square per mole. Siemens meter square per mole. Okay. Note down these two units. These are the units for molar conductivity. What is molar conductivity? Molar conductivity is the conductivity due to all the particles of 1 mole of the substance. Now come to the next part. Equivalent conductivity. Yeah, equivalent conductance. Equivalent conductance. As I told you, this complete chapter is a theoretical, and all these definitions are not going to ask in your board exam, but these are just the concepts. These concepts will helpful to understand the tomorrow's class. Tomorrow we are going to discuss most important topic, Kohlrausch law. So very, very important both for board exam as well as competitive exams. And Kohlrausch law briefly about D by Huckel-Onsager equation. Equivalent conductance. And just we have discussed about molar conductance. No, what's the definition I have given? Conductivity due to all the particles produced by 1 mole of the substance. You just make a small change. Conductivity due to all the particles produced by 1, instead of mole, you write gram equivalent weight of the substance. 1 gram equivalent weight of the 1 gram equivalent weight of the substance. That is called equivalent conductance, and it is represented by lambda eq. Lambda eq. Molar conductance is represented by lambda m, and equivalent conductance is represented by lambda eq. Okay, what's the definition for this? You write down the same definition. Conductivity due to all the particles produced by one here mole is there, no? In the place of mole, you write gram equivalent weight. 1 gram equivalent weight. So dear students, this class is going to end in 5 minutes. So I request you to rejoin the class for 15 more minutes, and we'll continue, and I will finish this basic concepts, so that in next class we can discuss the Kohlrausch law and all the applications of Kohlrausch law. Equivalent conductance lambda eq. Now here just a few minutes back I told you mole means number of moles, and we can calculate gram molecular weight and all we have discussed. For example, HCl hydrogen 1 chlorine 35.5, that is 36.5 grams, like that we discussed. But how to find equivalent weight? Equivalent, what is equivalent here? The equivalent represents equivalent weight. How to find? Actually, equivalent weight is equal to atomic weight by valency. This is the formula. If you don't know about this, again, this topic also I have already explained in the previous classes during our basic discussion. If you can watch that, that's okay. Now, for your understandability, just for 1 or 2 minutes, fastly I'll explain about equivalent weight by taking few examples. Now I'll take sodium, for example. Sodium, equivalent weight of sodium, E sodium is equal to atomic weight of sodium 23, valency of sodium is 1. How do we know valency is 1? Atomic weight by valency. How do we know valency is 1? Sodium atomic number is 11. Neon atomic number 10. Neon is noble gas. Okay. Noble gas, to get noble gas configuration, sodium loses 1 electron and becomes Na plus. So sodium always try to lose 1 electron to become Na plus. So otherwise you do like this. Sodium atomic number 11, nearest noble gas 10. The difference between these two is 1. So that is a valency. Equivalent weight of that is equal to 23. Equivalent weight of magnesium. I hope now you can do this. Magnesium atomic weight 24. Atomic weight 24. If you don't know atomic weights, please learn atomic weights. It's very, very important in this chapter and few other chapters also. Atomic weight of magnesium 24. And valency of magnesium. Magnesium atomic number 12. Neon atomic number 10. Difference is 2. So valence is 2. 24 by 2. That is equal to 12. Similarly, if I go to aluminum, equivalent weight of aluminum atomic weight 27. Atomic weight 27 by valency. Aluminum atomic number 13. Nearest noble gas neon atomic number 10. Difference between 13 and 10 is 3. So valence is 3. 27 by 3. 3 ones are 3 nines are. So 9. This is how equivalent weight we have to find for some certain elements. If you want to find equivalent weight of any compound, like for example, I'll take one small compound. What we can take? copper sulfate, for example, copper sulfate. Now it's here actually in this chapter, later I will explain you. In this chapter, when copper sulfate is given, probably we are going to take the equivalent weight of copper metal, right? Is the valence is 2, Cu plus 2, SO4 minus 2. Valence is 2. Okay, copper atomic weight, suppose equivalent weight of copper, if I want to take, equivalent weight of copper is equal to atomic weight of copper. Atomic weight of copper is approximately, it's around 65, I think, 65 by 2. Some fractional values are there, and later I will explain about this. 65 by 2 is approximately 2 ones are 2 threes are 6, and 2 twos are 4, and 1 is left, and we have applied point, and 2 fives are okay. Actually it comes around 63.5, 31.75, 63.5. Okay, copper 63.5. The 63.5 by 2 will get 31.75, approximately 32 will get. So later we'll discuss about all this. So likewise we find equivalent weight. So equivalent weight is equal to atomic weight by valency. Otherwise, if you get any molecular weight by valency we use. Now, equivalent conductance. Equivalent conductance means it is the conductance due to 1 gram equivalent weight of the substance. I hope you have written this, and it is represented. Okay, just a few minutes back, we have discussed on formula of molar conductance. What is the formula of molar conductance? Molar conductance lambda m is equal to K into 1000 by m. Here m is molarity. M is molarity, right? Now, note down the formula of equivalent conductance. Equivalent conductance is equal to K into 1000 by n. K into 1000 by n. For molar conductivity, what we have written? Molar conductivity lambda m is equal to K into 1000 by m. Okay, here small difference. Here this is equivalent conductance, this is a molar conductance. Here K is not K, actually it's a kappa, and it is called conductivity. Here also it is kappa, it is a conductivity. Actually it should be written like this. Okay, now here N for normality, M for molarity. This is normality, this is molarity. About normality and molarity we'll discuss later. Actually this chapter comes after solutions. Before this chapter solutions is there we'll discuss in detail about normality and molarity, right? These are the things you need to remember. Now finally, and one most important topic, just 10 minutes, takes 10 more minutes. Factors, all of you note down, please note down. Factors affecting electrolytic conduction. Factors affecting electrolytic conduction. Factors affecting electrolytic conduction. Here, okay. One second. Okay. Factors affecting electrolytic conduction. First factor, note down these factors. First factor, inter-ionic interactions. Inter-ionic interactions. Inter-ionic interactions. You have to understand what are inter-ionic interactions. To make you understand, I'll take a small example. Let it be a beaker filled with water, and then I have put some NaCl, sodium chloride, salt. NaCl is nothing but salt. And when we add salt to water, it produces Na plus and Cl minus ions. Right? Now there will be some attraction between Na plus and Cl minus ions, no? Because positive charge and negative charge. So this is called inter-ionic interactions. That means attraction or interactions between opposite charges, Na plus and Cl minus. These two ions are attracting with each other. One small question to you, anyone can answer. One small question. If inter-ionic interactions are more, and how about its conductance? If two ions are there, Na plus and Cl minus, these two are interacting very strongly. These two are attracting very strongly. Can they move freely? Can they move freely?
No, sir.
No, they cannot move freely. That means their movement is hindered. Their movement is stopped, or movement becomes less. So then when intraionic interactions are more, and their electrical conduction becomes less, right? So what we can say, interionic interactions is a conductance. Write down. Conductance is inversely proportional to inversely proportional to inter-ionic interactions. Conductance is inversely proportional to inter-ionic interactions. That means if inter-ionic interactions are more, ions will be strongly attracted with each other. Then ions will not move freely. When the ions do not move freely, automatically their conductance becomes less. And the second factor, the solvation of ions. Second one, these are all the points given in your textbook. Solvation of ions. I'll tell you what is solvation. Suppose this is a beaker and it is filled with some solvent. This is solvent. Say for example water. Generally we'll take water as a solvent, and then we have dissolved some solute in it. Say for example NaCl only, we'll take NaCl, sodium chloride, NaCl, Na plus Cl minus ions. If these Na plus ions, sodium ions, are surrounded by water molecules, if Na plus ions are surrounded by water molecules, H2O, 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 that means the positive ions are surrounded by water molecules here. This is called solvation or hydration. One small question to you. When during solvation, I'll take two examples. Let it be some ion A plus. It is surrounded by more number of water molecules. And another particle B plus. It's surrounded by less number of water molecules. Here more number of water molecules, here less number of water molecules. Among these two, means here solvation is more number of water molecules are surrounded the ion. Here ion is surrounded by less number of water molecules, so solvation is less. What is solvation? Solvation is the what to say, if any solute particle is surrounded by solvent molecules, that's called solvation. If solvation is more, the particle size becomes more. If solvation is less, the particle size becomes less. Among these two, which will move freely? Which will move freely? The bigger one or smaller one?
Smaller one.
The smaller one move freely. Very good. That means this smaller one move freely. That means in which the salvation is less. If salvation is less, the movement becomes more. Just one small example. Two students are there. One is a fatty student, another one is a lean student. When we keep some running race competition, the fatty students move slowly. Obviously, the lean student runs fastly. So similar to that, if the salvation is less, that particle size also will be less, and it moves very quickly. So then its conductance will be more. That means what we can say, conductance is inversely proportional to salvation. Write down. This is the second relation. Conductance inversely proportional to salvation. If salvation increases, conductance decreases. Next one, viscosity. Viscosity. Here, viscosity means just in the first case I told you, no, if interionic interactions, if interionic interactions among the solute becomes more, conductance less. So viscosity also you simply write down. Conductance is inversely proportional to viscosity. Conductance is inversely proportional to viscosity. That means if viscosity increases, conductance decreases. Next, fourth relation, temperature. Can you say anything about temperature? If temperature increases, what about the conductance? Suppose if I take a beaker, some solution, and now you are heating. Now you are heating to this, and we are heating here. Heat. Then what happened to the molecules present in the solution? These molecules move quickly now when we heat, when we increase the temperature. These the in the first year in 11th class you might have studied the kinetic energy of molecules directly proportional to absolute temperature. That means when temperature increases, kinetic energy also increases. That means when temperature
Yeah.
increases, the molecular movement also increases. When the molecular movement increases, conductance also increases. So conductance is directly proportional to temperature. When temperature increases, electrical conductance also increases. But there are some exceptions. This is we are discussing about molten solutions in liquid state, not for solids. Okay, next, dielectric constant. Fifth one, dielectric constant. It's not so important, but better to remember. Dielectric constant. Uh, do you know water is having highest dielectric constant value? Dielectric constant of water is very high. That means whatever we dissolve in water, water makes many things to dissolve in it. So water is called universal solvent because water can dissolve many things. Water can dissolve salt, water can dissolve sugar, water can dissolve urea, water can dissolve alcohol, many things. So it is called universal solvent because it is having high dielectric constant. So when dielectric constant is more ions will be produced due to dissolution and conductance will be more. So conductance is directly proportional to dielectric constant. Now down, this is one more relation. So, and finally, one more concept is there. Last one, I think sixth or seventh. The last one is sixth, no? This is seventh one. Last one, dilution. With this, we'll stop this class, and tomorrow we'll continue Kohlrausch law and all. Dilution. This is very important to understand Kohlrausch law and all. Dilution. One small example I'll give. You try to answer. I have taken some water in a beaker, and say, for example, this is 1 liter water, and I put some 100 grams of NaCl, sodium chloride, into this. 100 grams of NaCl. When I take NaCl, Na plus Cl minus ions will be there. Many Na plus and Cl minus ions will be there. Now these Na plus Cl between Na plus and Cl minus, there will be interionic interactions because these are oppositely charged, positive, negative. isn't it? Uh, Now, what I do, due to these interionic interactions, they cannot move freely. They cannot move freely, isn't it? Now, what I do, I'll add some more water. Some 1 more liter I have added. Now, the quantity of water becomes 2 liters. 2 liters. Then what about the interionic interactions between Na plus and Cl minus ions? You please tell me. If I add some more water, but I have not increased the NaCl. NaCl is 100 grams only, but quantity of solvent I have increased. Quantity of
They
water I have
move
increased.
freely.
That is called dilution. I have diluted it. When I have diluted it, what happened to the interionic interactions? Interionic interactions becomes more or less?
Less.
Less. Very nice. Less. A very simple example. There are two swimming pools, one small swimming pool and a big swimming pool. In small swimming pool, here NaCl we are not going to increase, 100 grams only. In a small swimming pool, some 10 persons are there. In a big swimming pool also 10 persons are there. In which,
ఇద్దరికి క్లాస్ చెప్తుండు మా ఆయన
in
ఇద్దా
which,
ఇది
in which,
ఆయన
hello? In which case, these the people will swim easily because the size of the swimming pool is huge, big. Here the people can swim very freely and easily. But when the swimming pool size is less, people cannot swim freely because same 10 persons, but the size becomes more here. That's a similar example. See here, dilution. Dilution means what? Adding more and more solvent, more water. When you add more water, these ions move. These ions move away from each other. They can move freely. And you can take example of swimming. That's how you can understand easily. And swimming in a well, swimming in a well, and swimming in a river. And that's a simple example. And in well, swimming is a little difficult because space is very less. But in river, as a river is very big, we can swim very quickly. So that means on dilution, what happens? Tell me. On dilution. Dilution means adding water, adding solvent. On dilution, what happens? Conductance increases or decreases? Conductance means what? Movement of ions. Ions move freely or ions do not move freely? On dilution,
move
and move freely.
move
On
freely.
dilution, ions move freely, so conductance increases. Write down this. On dilution, conductance increases. That means dilution, conductance is directly proportional to dilution. Conductance is directly proportional to dilution. So, dear students, total 7 points we have discussed here, and try to get this concept. Interionic interactions. So, if interionic interactions are more, conductance will be less. So, conductance and interionic interactions are inversely proportional. Solvation of ions. If there is more solvation, means if the particles are surrounded by more solvent, the size becomes more and they cannot move freely. Small ions move freely than large ions. So, conductance is inversely proportional to solvation. Viscosity. Viscosity also similar to that, the previous one. So, conductance is inversely proportional to viscosity. Temperature. When temperature increases, kinetic energy increases. Obviously, the conductance increases. So, conductance and temperature both are directly proportional. Dielectric constant. When dielectric constant increases, conductance also increases. And finally, dilution. When dilution increases, then also conductance increases. So these are the important things you need to know. These are all theoretical topics. These may not be important for your board exams, but for important for your competitive exams. And tomorrow we'll discuss. Probably tomorrow class may not be there, but I will inform you through WhatsApp message. If class is there means the same time. And but don't miss the next class, coming class, tomorrow's class, coal rash law. It's a very, very important, and its applications also we'll discuss. And we are getting very frequently in a board exam as well as in competitive exam also the questions based on coal rash law. Okay, we'll meet tomorrow or day after tomorrow. Okay, take care. Good night. Bye bye.